Welcome everybody to this video. If you're watching this video, more than likely the test didn't go so well for you. And one of the things I'm going to remind you of is every one of these questions that you see here, you had the answers to. We've gone over in class. We may not have gone over it word for word, but we've covered everything on here. Some of these you actually saw word for word in some of the review videos, and I'll point that out as we're going. So what you're going to do is you're going to use this to create your corrections. So I'm going to hand you a guide. I want you to go through and I want you to fill out the guide so that you're ready to retake this test. So here's the first question. Now, first of all, this question was in the review videos. So if you would have watched a review video, you would have seen this question answered. So it should have been a slam dunk. So if you got it wrong, you shouldn't have. So in which of the three positions does the apple have the most gravitational energy? Now the drawing shows an apple falling to the ground. Position 3 is the instant before the apple hits the ground. Some of you didn't read this part because some of you told me in your answer that, oh, it doesn't have any speed, it's already hitting the ground, it stopped, it has elastic energy. But if you would have read this information, you would know it's the instant before it hits the ground. So which one do you think it is? Which one's going to have the most GE? So here, it's position 1. It looks like it just started to fall. You have one in the middle and one just before it hit the ground. So the correct answer should be number 1. Now the key is why. So remember, gravitational energy is dependent on elevation and mass. The mass does not change here. So you just need a really simple answer. It has the highest elevation. It's got the greatest elevation. It's the tallest of the three. It's got the most elevation of the three different positions. Something very simple like that is all you need to get credit. Position 1, why? It's the highest elevation. Now you notice it's 2 points. 1 point was for this part and 1 point was for this part. And again, I'm looking for highest elevation. So the next question is almost the same, except in which of the three positions does the apple have the most KE, or kinetic energy? So remember, kinetic energy is dependent on speed and it's dependent on mass. So when we back up, GE was dependent on mass and elevation. Now this one is dependent on speed. So if it's got the most KE, again, we know the mass does not change. So what must change to speed? So it's got to be position 3. And a lot of people have a common wrong answer. They say, oh, it's 3 because it's the lowest and it's had the most time to have the GE convert over the KE. I'm not giving you credit for that. You got 1 point for this, but to get the other credit, you just simply need to say this is where it's got the greatest speed. This is where it's moving the fastest. Yes, it's fallen the longest and has the most time for GE to convert to KE, but if you did not say it's moving the fastest or it had the greatest speed, you are not getting credit for this. We've talked about this. In fact, a question very similar to this was on the last test that we had. So it's not a new question. Plus, this part up here, you saw word for word in the review video if you watched the review video. All right, so in which position is the apple's total energy the greatest? A lot of you got this one wrong. Again, this part right up here was in the review video. If you would have watched the review video, you would have gotten this correct. So which one is it? Is it position 1? Is it position 2? Is it position 3? Well, none of them. All the positions have the same amount of energy. They all have the same total energy because the total energy in the system has to remain constant based on the law of conservation of energy, which was scientific principle number 7. The energy is converting from GE to KE, the thermal energy, and back and forth and back and forth. Well, on the way down, it's not going back and forth, back and forth. It's just going GE to KE and it's picking up some thermal energy. But the amount of energy stays constant. Energy cannot be created. It cannot be destroyed. So I'm looking for an answer like none of them or all of them have the same amount of energy, and then you get credit. Again, it's 2 points. You have to tell me that none of them have the most or all of them have the same amount, and you have to have an explanation. So whenever you see 2 points, I'm looking for 2 different answers, or not 2 different answers, but 2 parts to the answer. All right, so number 4, can light be considered a type of energy? Explain your answer. Now before you do this, can you guess where you've seen this question before, or you might have seen this question before? The review video. So again, if you would have watched the review video, you would have gotten this correct. Why are you choosing not to watch the review videos? I've told you over and over, a lot of the questions are on there. So why would you choose not to look at the answers? So explain your choice. So again, it's 2 points. 1, can light be considered a type of energy? So light is energy because it can be used to do work. So you notice I said light is energy. So can light be considered energy? It says light is energy. Some of you never answered this part. Can light be considered a type of energy? Light is energy because it can be used to do work. Solar panels convert light energy into elastic energy, or this is actually electrical energy, sorry, and thermal energy. The radiometer gains Ke when the LED is shined on it. Light is energy because it can be converted, transformed to other types of energy. So what am I looking for? Yes, it can be converted. Light is energy. Something tell me that it can be. Now, the best part of the answer is this bottom one. Light is energy because it can be converted / transformed to other energy types. That's what I'm looking for that second point. If you would have just given me, oh, solar panels convert light energy to electrical energy, I didn't give you the second point. I gave you the first point, but I didn't give you the second point because it's not enough. Now, if you would have mentioned this, and you would have mentioned this one, and you would have talked about how light can be converted to all these different types and gave examples, great. But if you just had one example and didn't say it can be converted or transformed to other types of energy, you didn't get that second point. Again, 2 points, make sure you have 2 things to say. All right, so next question. Now, did you see this question word for word in the video? No. But we covered this in class. It came from activity 8.1 and 8.3. So even if you were gone or absent and you weren't done with this, we gave you the data. So it says, use the data table above to identify the relationship between chemical energy and the mass of the substance. Some of you lost points because you never identified the relationship. Some of you said, oh, when we had 0.5 grams of aluminum foil, there was a 23-degree change. And when we added 0.8 grams of aluminum foil, there was a 43-degree change, or 43 degrees Celsius change. That's great. I gave you a point, but you never identified the relationship. So what is the relationship? If you increase the mass of aluminum from 0.5 grams to 0.8 grams, there will be an increase in the amount of chemical energy produced by the copper chloride solution and aluminum soil reaction. Did I answer that yet? Yeah, kind of, but hold on. The opposite is also true in general. So here it is. If you increase the mass, you get more of a chemical reaction. So somewhere along the lines, you got to say, if you increase the mass, you're going to get more CE. Now, the second part of this, more people miss this part. It says quantitative data. You have to use numbers in it. So I used numbers here, and I said the change was a 20-degree Celsius difference. So between 23 and 43 was 20 degrees difference. So I not only said, yes, if you increase the mass, you get more chemical energy, but then I used quantitative data to back it up. So some of you got the first part right, but you never used any quantitative data. Some of you used quantitative data, but you never explained the relationship or identified it. And then the last question, again, this goes along with the scientific principle for chemical energy, where if you increase the mass of the substance that you're using, you're going to increase the amount of CE as long as the substance stays the same, and the opposite is also true. This is the other part of it. If you change the substance, you will change the amount of chemical energy as long as the mass stays the same. So here again, now we're comparing the 23 to 5. You notice they're both 0.5, so mass is the same. But what are we changing here? We're changing the substance. So identify the relationship between chemical energy and the type of materials. Well, in general, the type of material used affects the total amount of chemical energy produced. That's the first part, but it's worth 2 points. What's the second part of it? Well, the second part is the quantitative data. So if you change the material used from aluminum to steel wool, or you might have said, we changed the material from 0.5 grams of steel wool or aluminum foil to 0.5 grams of steel wool. When we used 0.5 grams of aluminum foil, we got a 23-degree change in Celsius, and when we changed it to steel wool, we only got a 5-degree change in Celsius. Therefore, the type of material used affects the total amount of chemical energy produced. So you notice I answered both parts. So some of you just don't read the whole question, where it says, yeah, identify the relationship, and then it says explain your answer using specific quantitative data, which some of you didn't do. So you got to make sure you read the whole question. So the expectation is that you have the questions on the test that you had wrong fixed. Again, you're going to be able to use these notes to help you retake the test. The expectation is that everybody retakes the test. Make sure you ask me any questions if you have them. Thank you.